what are known as polar coordinates. Polar coordinates are given by r theta. So they're called polar coordinates, or they're also called cylindrical coordinates. I just call them cylindrical coordinates. Okay, so the path of the particle is this. Okay. And let's assume that this is the origin. So it starts over here and goes in this direction. What we can do is we can try to find the distance of the particle at some instant of time from the origin O. Okay, that's basically denoted by r. So we draw a vector which is along the unit vector along r, and then we draw a vector which is normal to r. It's called u theta. So then this angle here is theta. So when you can describe, when the motion of the particle is best described in polar coordinates or cylindrical coordinates r theta, you're better off using this coordinate system, which is taking a unit vector along r and unit vector along theta. So the simplest example of the polar coordinates would be moving on a circle, right? Where r is constant, equal to the radius of the circle, and theta is the angle made with, say, the x-axis. But it doesn't have to be that r is constant. You will see questions where r is not a constant. So whenever we have r is a function of theta, we would use polar cylindrical coordinates. Okay, so far we've learned three types of coordinate systems. The rectangular coordinates, where motion is along the x, y, z axis. Second was the tangential normal coordinates, where you could represent motion along the normal component to the curve and tangential component. And the third one is r and theta. Note that theta is not tangential. It is not tangent to the curve which is drawn in red. Okay, it is at an, it need not be at a tangent. It has to be normal to r, and r is not normal to the curve. So that's how this coordinate system differs from the previous one, normal tangential coordinates. Okay, so once we have this coordinate frame, the question is, how do we describe motion using this coordinate system? So position is described using, I'll describe it using r. It's simply r times ur. Okay, so the distance from the origin times the unit vector along r. To find the velocity, all I need to do is differentiate r with respect to time, or in other words, this is dr dt. So when you take the derivative of r ur, you got to use the chain rule, right? R dot times ur plus r is constant and ur dot. Okay. I will not go through the derivation, but there is a derivation in the book which tells you how to take that derivative. Turns out that this is equal to, it'll have both components, vr ur plus v theta u theta, and the book gives you a formula for vr and v theta. Vr is simply r dot, where r dot is dr dt, times ur plus u theta is r theta dot u theta. Okay, I'm going to write it here r dot is d r dt, theta dot is d theta dt. Okay, the next thing we want is acceleration. Acceleration is obtained by taking the derivative of velocity with respect to time. So A is the acceleration, it is dv dt, and again when you use that formula, you're got to use the chain rule to find that the derivative of v. So it's much more complicated than the previous one because now you have two terms. In fact, there are three terms in here, and you have to keep this constant, take the derivative, keep two constant, take the derivative of that, keep the other two constant, take the derivative of the second one, and so on. So you get like three terms out of that, two terms out of the first one, and when you do a simplification, you end up with something which is much simpler. So this is, I'll write it as AR UR to denote the component along UR, and A theta U theta, where A theta is the component along theta direction. So it turns out to be R double dot minus R theta dot square UR plus R theta double dot plus 2 R dot theta dot U theta. Okay, where clearly R double dot is d square R dt square, theta double dot is d square theta dt square.
So UR and U theta are direction?
Yes. Unit vector along R, and this is a unit vector along theta. Okay, anything else? Okay, so we see this will come again, this equation. This is known as the Coriolis acceleration. If you've not heard of it, and that's this thing is called as centrifugal acceleration. This will come again later when we do Newton's laws. So this formula is in your formula sheet. You do not have to remember the formula. Okay, so what we'll do is we'll try to see how to apply these formulas and do some word problems. Okay, a particle is moving along a circular path having a radius of 4 inch such that its position as a function of time is given by theta equals cosine 2t, where theta is in radian and t is in seconds, where clearly t is the time. Determine the magnitude of the acceleration of the particle when theta is 30 degrees. So in this question we are asked to find acceleration. In fact, we want to find the magnitude when we're given that r is 4 and it's a constant. It's a constant because this particle is moving along a circle. right? It's moving in a circle, so r does not change with time. And we're given that theta is equal to cosine 2t. Okay, I'm going to draw this slightly differently. The way this moves actually is r and theta. Okay, so what we'll do is we'll try to work it backwards. So we'll try to see what we want to find out, which is acceleration, write a formula for it, and see what we need in order to solve for acceleration. So the acceleration is given by r double dot minus r theta dot square u r plus r theta double dot plus 2 r dot theta dot u theta. I got this formula from the previous slide. If I want to find the magnitude of the acceleration, all I need to do is take the r component, square it, and add it to the theta component after it's squared. So 2 dot theta dot square. So all I need to do is now find what r dot, r double dot, theta, theta double dot, and theta dot is, and I can solve for acceleration. So let's start with r and its derivative. R is 4. What's r dot? It's 0 because the radius does not change with time, it's a constant. So then dr double dot would be 0. Okay, then I need to find theta. Well, theta is given to be cosine 2t. I need to find the first derivative, which is derivative of cosine is negative sine. So negative sine 2t. I also need to take the derivative of 2t. So the derivative of 2t is 2. Minus 2 sine 2t. And then finally theta double dot is the derivative of sine is cosine. And then I have to take the derivative of 2t, so that's 2. Okay, so I have a formula for r, its derivatives, and theta and its derivatives. However, I'm not able to find a numerical value for acceleration because I do not know what t is. So if I can find t, then I can find what theta and its derivatives are, right? How can I solve for t? So we know it's 30 degrees. So right, so we know something about theta. We need to find time t when theta is equal to 30 degrees. So I'm going to shove this in this equation. Theta is 30. Now when you take theta is cosine 2t, you want to take theta in, will you put 30 degrees? So if you put 30, it doesn't make sense because cosine can only be from -1 to +1, right? So you cannot put 30. You need to put the value in radians. So it's going to be pi divided by 6, which is 30 degrees, right? Equals cosine 2t. So if you solve for t, so to solve for t, you need to take the inverse of cosine. So this is going to be half cosine inverse pi divided by 6. So if you solve for t, you get 0.51 second. Okay, so now I can solve for theta dot. I need theta dot and theta double dot. So theta dot is minus 2 sine of 2 times 0.51. It comes out to be negative 1.7039 radians per second, and theta double dot is it's 2 times 2 is 4, so minus 4 cosine 2 times 0.51 comes out to be minus 2.094 radians per second. And so showing it in the formula, I can now find A. Okay, A is well, I did it this way. I first found what A is, the vector A is. So it comes out to be 11.61 UR minus 8.38 U theta. And so if you want to find the magnitude, it's simply negative 11.61 square plus negative 8.38 square. That is 14.3. It's going to be the same units in which R is. So R is in units of inch. So it's going to be inch per second square. Yeah.
Just make sure when you got negative 11.
Yeah.
You just plug it into that formula, right?
Yes, I use this formula, yeah. This one. Yeah, because R double dot is going to be 0, so it's going to be R times theta dot square.
Is that negative 11.61?
61, 11.61. Okay, any questions? Okay, so yeah.
Sorry, you said that was 14.3?
14.3.
Okay.
For which the distance is defined by R equals 200 divided by theta in feet, and theta is in radians. If it maintains a constant speed, so v is 35 and it's a constant. Determine the radial and transverse component of velocity when theta is pi divided by 3. Okay, so the radial is clearly r and transverse is theta. Okay, so we have to find let me write the velocity vector first. It's vr ur plus v theta u theta, where clearly vr and v theta are the radial and the transverse component. So vr is r times theta dot. Is that right? No, that's not right. It's r dot ur plus r theta dot u theta. So we got to find r dot and r times theta dot, and we are done. So this is the first unknown, this is the second unknown. Okay, so since we're given r, let's try to find what r dot is. So r dot is dr dt. So it's going to be d dt of r, which is 200 divided by theta. So 200 comes out. The derivative of theta, 1 over theta, is minus 1 divided by theta square, right? D theta dt. So derivative of 1 divided by, say, x is minus, so you have to do x raised to minus 1 and then take the derivative of that. Okay, so it looks like in order to solve for r, we need to know what theta is, which we know. We do not, however, know what d theta dt is. Okay, we also need to know theta dot. I'm going to write this as 200 divided by theta square theta dot. Okay, so we also need theta dot here to find the transverse component. So it looks like I just need theta in order to solve this problem. Sorry, theta dot to solve the problem. But I'm not given theta dot. I'm given this, but I have not used this information so far. Let's see if I can use this information. So V is 35. Okay, that means that the magnitude is 35. So the magnitude of V is 35 is equal to square root of r square, so this component, sorry, r dot square, this component, plus r theta dot, the transverse component, square. Right, this comes from here, the sum of the x and y components, but we need to square them. Okay, so r dot is right here, 200 theta square times theta dot square plus r times theta dot. So r is given as 200 divided by theta, and theta dot is an unknown. So right here in this equation, turns out the only unknown here is theta dot, because theta is pi divided by 3, right? That's given. So if I have one equation and one unknown, theta dot, then I can solve for the unknown. So theta dot comes out to be 0.13.
How do you solve for it?
Oh, how did I solve for it? Well, you got to take the square and then square of this, then you'll end up with a fourth order equation, because you get theta, you get theta square. You know that, you don't know theta dot. So theta dot square, you can pull it out, and you can basically find the value of this because you know theta. And then it's a matter of fixing that 35 equals, right? Yeah, so it's pretty simple. It's not, there's no fourth order. Yeah.
No, it's awesome. The formulas, what formulas you given?
The formula sheet is on Blackboard. So if you look at the course homepage, the formula sheet, it will give you the same formula sheet for the whole semester, because there's formulas for the entire course. So you should see this formula somewhere in the formula sheet.
Okay. Just one hour.
Okay, so after you solve for theta, well, we need to find VR. That's pretty simple now, because we know VR is r dot. Okay, I'm just going to write the final answer, but you can see that you can solve that because you know theta dot. 24.2 feet per second, and V theta is r theta dot is equal to 25.3 feet per second. Okay, so where did I get this from? Well, I got this from using this formula here, and then r is 200 divided by pi, no, theta, okay. So it's pretty straightforward application of the formula. Okay, so last question, and I'll let you go. A particle moves along a path such that r equals 2 times cosine t, and that is in feet, and theta equals t divided by 2 radians, where t is in seconds. Determine the particle's radial and transverse component of velocity and acceleration. So in a sense, it's asking me to find VR, which is r times the, sorry, it's r dot, v theta, which is r theta dot, AR, which is r double dot minus r theta dot square, and A theta, which is r theta double dot plus 2 r dot theta dot. Okay, so I need to find these four things: velocity, radial and tangent, transverse component, acceleration, radial and transverse component. So as long as I can find r its derivative, theta and its derivative, I'm good. So let's try to solve for r and its derivative. So r is 2 times cosine t, r dot, which is the first derivative of r with respect to time, is 2 sine t, and then the second derivative is minus 2, derivative of sine is cosine, so that's it, and then theta is t divided by 2, theta dot is just half, and theta double dot is 0. Okay, so VR is r dot, which is minus 2 sine of t. V theta is r times theta dot, so r is 2 cosine t times theta dots, which is half. So this is just cosine t. AR is r double dot, which is minus 2 cosine t minus r, which is 2 cosine t times theta dot square, so half square. That comes out to, I think, 3 divided by 2. No, it's 5 divided by 2. 5 divided by 2 cosine of t. Yeah, that's right. And then A theta is r times theta double dot, but r is 2 cosine t, theta double dot is 0, plus 2 r dot, which is minus 2 sine of t times theta dot, which is half. So this would give me, I think, minus 2 sine of t. So in this case, I'm not able to find a numerical value for the velocity and acceleration because I'm not given the time t. But if I was given that, I could have found the numerical value. So this is a problem. This is the previous one, the problem where the r is not constant. It's actually a function of time. Okay, so that's it for today. I'll see you on Friday. Please study for the exam, and we'll have a more productive class if you come prepared for the exam on Friday. This is not going to be there. It's only homework 2. Everything we covered till last class.